Hello and welcome to another Reigate Maths video focusing on the pure content from the second year A-level maths syllabus. In the field of trigonometry, this video is looking at a couple of examples for proof of identity type questions. This is typically a topic that students find very difficult, mainly because not knowing where to start or that kind of thing. So hopefully these two examples will give you a little bit of some guidance with that. So the first example here, we're going to show that cot of a plus b is equal to cot a cot b minus 1 all over cot a plus cot b. So this one we can see a few things. Obviously we have a reciprocal trig function. We've got this cot here. Okay, so we're probably going to be using either 1 over tan or cos over sine. Which one we'll decide later. We've also got an a plus b, so we're going to have to use a addition formula. Maybe more than one. Now, the thing that, for me, tells me we're going to use cos over sine instead of tan is this here. The fact that we've got cot in our answer a lot of. Cot is 1 over tan, for sure. So if we start going down this route, chances are we're going to end up with lots of 1 over tans all over the place, which may well get us the right answer, but it's a little bit more... It's going to be potentially harder to read, harder to write down, and ultimately potentially harder to do. So let's have a look at using the cos over sine. So because we are proving an identity, we start with the left-hand side, or the right-hand side, but in this case, the side we can do more things to, or the side we know a formula for. So this is cos over sine. Now we know the addition formula for cos. Remember, it's in the formula book. So we've got cos A cos B minus sine A sine B over the one for sine A plus B, sine A cos B plus cos A sine B. Now the thing with this one is, as well, if you cast your mind back to the video where we introduced these addition formulae, we went through the proof of the one for tan. This is actually pretty much exactly the same thing. But instead of dividing by cos A cos B, we're going to divide by sine A sine B. How do I know that? Well, let's look at what we're trying to get to. We have a 1 on the top, or we have a minus 1 here. And we've got a minus something here. So we want this minus something to become a 1. How do we make something be 1? Divide it by itself. So we're going to divide top and bottom by sine A sine B. Okay, so doing that, again, this is going to get a bit of a mess, but we'll do our best. We're going to get cos A cos B over sine A sine B minus sine A sine B over sine A sine B all over sine A cos B over sine A sine B plus cos A sine B over sine A sine B. And now, like with the tan proof, things are all going to cancel out and simplify. So cos A over sine A times cos B over sine B, which is what this can also be written as, is going to be cot A cot B. We've already established that that's going to go to be 1. The sin A's are going to cancel here, and we're going to get cot B. The sin B's are going to cancel here, and we're going to get cot A. Now I know it's not written exactly the same way round as here, but cot A plus cot B is the same as cot B plus cot A. So we don't actually need to do any more. We're done. So as I said with this example, the key thing is knowing what to do here. And that's all about looking at what we're trying to get to. We can see, again, that we've got this -1 here, and we've got a minus sin A sin B here. Again, the way to make something equal to 1 in a proof is divide it by itself, and then you've just got to remember to do that to everything. And that's kind of the trick with this proof. It works, going down a route with 1/tan, it just gets a lot messier. So this is the more concise way to do this proof. Here's our second example. Now, again, there are lots of ways we can do this one. You can see here that this is kind of in that R alpha simplified form that we looked at in a previous video. We've got R here, we've got our angle, and we've got our alpha. So that's one way you could do this question. However, an easier way would be to use the addition formulae again and basically do the R alpha method backwards. So this is what's really important about this type of proof. You don't have to start with the left. Typically you will, but not always. And in this case, if we start with the right hand side, we're actually going to get a much simpler solution. So here, our right hand side is 2 cos 2x plus pi over 3. If we expand this using our addition formula, we're going to get 2 cos 2x cos pi over 3 minus, because remember the sign changes, 2 sin 2x sin pi over 3. Now using our calculator or using your memory, we know what cos pi over 3 and sin pi over 3 are. But because we could very easily jump from here to our answer, we can't do that. We need to make sure it's very clear that we know, or that we're evidencing, cos pi over 3 and sin pi over 3. Now we're there, we can jump to our answer. But that's one of a multitude of ways that you could do this example. And again, with both of these examples and any trig proof of this type, it's all about just looking at the question and figuring out what identities you need to use. Take the time when you're practicing to have a go. If you don't know what to do, don't just stop. Try something. No one's going to shout at you if you get it wrong. No one's going to judge you if you make a mistake. All you need to do is try something. If it works, great. If it doesn't, oh well. It didn't work, try something else. If you do a question, if you start a question 4 or 5 times while you're practicing at home or in class, that's fine. What you want to get to is the point where you've practiced enough and you know, oh, I'm going to look at this question. I've done a question similar to this and I got it wrong a bunch of times, but I eventually got it right and this is what I did. That's where you want to be when you sit your exam. Thanks for watching.